morning. Here I'm going to introduce generally which talk about bottlenose dolphins, double-slit, pupil, asymmetries, and enhanced visions. And my name is Ray. And first, I would like to talk about asymmetry, which means not is two part of thing which is not totally the same, and it has a little bit difference, which means the pupil of the dolphins is not exactly the same. And I would like to ask you a question first. What if us see underwater without a swimming grass? And I believe it will look like this. Sorry. And what if a dolphins look underwater? It will be very clear. So here's the question. What if a dolphin look on the aerial? It's only a gas. It also will be clear, but why? And coming up, we will talk about this. The introduction. And echolocation is an ability of dolphins which can help them to detect how far is the target. Like it can help them to know the target or something around them. And in the research, we can find that as the light decreases, that they depend more on the echolocation. That means the ability of echolocation is increased. And in the introduction, we have found that some scientists have made an experiment of the dolphins, which they make a mass of structure for the dolphins to let them find a way out. And we discovered that as the dolphin can swim faster, and they are not really depends on the echolocation. But why? It's because they use the vision as a sensory input. So there will be a curiosity that why the dolphins can use the vision as a sensory input in the dark side and on both the brightened side. So here's the materials and methods. We use a dolphin which is called pupil, and we take a photo with it. And we can see that the pupils of the dolphins becomes a bean shape. And it is not usual as we see. And it's talk about a geometric ray. Geometric ray is tracing through a length overcorrect. It means whatever its length becomes a weak length in air, or it becomes a strong land coat in water, we can use a biocomputer length eye model to do the research. And in this experiment, we are not really using a dolphin eyes, but we will use a model like a link eyes to predict how its eyes works. And in this experiment, we will use this program, which called Aquatic Visual Engineering Environments and the Labs program. And we will collect the data of the eyes model and compare and separate plots for each data group of data. And we will determine the relative goodness of it and the result. And here is the bifocal lens eye model. We will use this idol to test. And we find that in the left eyes of puka, there is 30 degrees, 45 degrees, and 60 degrees that the eyes can absorb light. And we find that the thin beams of light focus on the temporal areas centrals, which means when the dolphins contrast its eye pupils, it will become a thin shape, and the light will focus through the ring's shape, but not the total pupils. And here is the result. And there is complicated for us to deal with several variables. The first one is the dolphin using the sense in any time, so that we cannot predict how the lights change in any time. And second, the range of dolphin activities area is large, which means they will go in light side and the dark side. As the research said, dolphins can swim deeply and like they can diving into 300 meters. So that from a very large range of light conditions, we cannot ensure how their pupil change. And the third one is vision is affected by pupils, so that it's difficult for us to predict how the dolphins will ever change its pupil. We can just do the test to study how its pupil work. And the iris change the shape of pupil under a brightened environment, which means underwater they can use for focus the wave, and in the aerial pupils will contrast and it can cause a clear image. Like when it is underwater, the shape of the dolphin's pupil will look like a circle, but when it has too much light, it will change into a kinetic beam size like this, just like the first picture we see on pupil. And so that we get a result of a large rostral pupil in water, or which means in water it will use large size of pupil, but in air, which have a high brightening light, it will use a temporary pupil, and the pupil cause a V shape. And here's the discussion. We will use human to compare to dolphins. It is an image size. Image size means if people using face mask underwater, we will see the things become bigger. And it's because the pace of the face mask to underwater, the distance ratio is 1 to 3, which means the things will be bigger as triple. But to dolphins, because their eyes degrees is 70.5 to 0 when they are, whenever they are on the air or underwater, so that their eyes have a stronger power of the cornea in air, and they have no problem to see in air or water. That means their pupil will contrast as they want, and they won't see the things which have a ratio. And here is some characteristics of dolphins' visions. The first is they can comparable aerial and underwater activities, which means they can completely see the things in air or underwater. And the second is there are a wide field of vision with a best resolution in inch of S in both air and water in the forest or downwards direction, which means whatever they look up or look down, their visions will become a resolution in XRs. And the third one is their eyes have two aerosymmetry and a bifocal lens. That means their eyes have two main central point, and they have a bifocal lens just like talk about it is model which the model we use which can measure as the area underwater, and we chop it. And the conclusion is on the long term, the central is working as a sensory input for dolphins. And this behavior study of dolphins is important because it can't be studied if they are dead. And the eyes will remain a subject of active research and debate as the knowledge is too less. Because in nowadays, there is too less information for us to study the dolphins. Thank you.
All right. So 1 minute, 10 seconds left. Q&A now. Edgar. Second, how to pronounce? Sky? Sky?
Yeah.
Okay. Forgot. Lena. Lastly, William. Okay, start. Edgar. Repeat his question.
It means how the dolphins works in watching the fish by pupils.
Vision.
Visions. Because the dolphins can control its pupils through control the light, so that if it's enough light for the dolphins, it can see the things clear. What I mean is when dolphins want to see the things clear, their eyes in water will become the pupil will become circle shape, and in aerial it will become a beam shape. And how to do this is by its iris to control, like it can dilate or it can constrict the pupils to see the clear visions.
Sky.
How to observe the pupil change and what the flying eyes model.
Oh,
Repeat her question.
To make the eyes model, they use the.
What is her question?
The question is what is we study the eyes?
Just one question.
Oh, how to observe the pupil change? It's underwater, and what you use to observe?
To observe the pupil change underwater, we will see the whale dolphin as like pupil. In the water, under the high light, we can see that its pupils become like a bean shape, and this also one reason which causes us to study this generally. And we have used testing eye machines to test the pupil's eyes.
Okay. Forgot.
It's nice to often use echolocation in the air. It's nice to often use echolocation in the air.
Repeat his question.
It's nice. Often often use echolocation in the air.
Repeat.
In the
What is his question?
this question is that dolphin will use the echolocations in the air,
No,
right?
it's not.
At night, or in the dark. Sure, we can use the echolocation at dark. The echolocation may not be really be the first sensory input for them, and it may be the we will use the eyes for the sensory input as first. Yes.
Lina,
Can you talk more clear about how the process of using wavelength to dimension are observation?
repeat again, louder.
Can you talk more clearly about how the process of using wavelength to dimension the observation?
Oh, so you are
Question,
asking
what
about
is the question?
you're asking about how we use the program to. So in the program, we have collect data and like using the ANS model to predict the degrees that the light have effect, and we have collected 8 part of data, and we will compare them and find is there BD to the same data to know how the degree is.
All right, cut here. William,
How should dolphin combine the echolocation and its vision input? And does it depend the light degree?
So you mean that instead using the echolocation and the vision together as the sensory input, right? So I think the dolphin have using them both together, but more likely they will use the using whatever is a high light or is a dark haze. They both will use the eyes for the sensory input, and the echolocation will be more likely for them to detect the unknown.
volunteer question, 1 to 2. What's your name?
In the previous slide, can you explain what is rostral pupil and temporal pupil? In the previous slide, for your result. What is rostral pupil and temporal pupil?
Rostral pupil will be likely that will be a long-term. It means it will be the dolphin's eye will be usually will be like a circle shape, but if it's in the air, like when the air have a flash of light through its eyes, it will become a temporal pupil, which means it will feel like a thin shape for less light to get into its eyes.
Why choose dolphin, not fish?
Because it depends on my individual's hobby. Like
I mean, this search why choose
Oh.
dolphin, not
Sorry.
choose dolphin.
this because I'm not sure, but I guess the writers would be likely to doing research about dolphins, and because the eyes of the fish may not using on the aerial, only the mammals, marine mammal animal will using their eyes both in water and in the aerial. So that again is the reason why the study doing like this. Thank you.
Okay, my turn. So, Wayne, first of all, I have to say you have chosen a very difficult paper. Are you aware of that? You regret it. This is at the beginning. The title looks sounds sexy. 双瞳呢? So wow, what's that? And that looks also wow. Okay, what's that? However, when you look closely, you start to figure out, what's that? I have no idea. I also check it, but I have no idea. Have you taken any lecture in anatomy? 解剖学. Then you will have problem understanding. So I saw that you barely presented any data because I don't think you understand it. Do you? The data? But you didn't present any of them. So I mean any of the figure here. I think these are because the author cited a lot of previous work. So I think the only real work done by the author is like this one. I don't know if it's done by himself. This one and this one. However, I have problems understanding it. So I don't know. Okay. So that's a really problem if you choose a very difficult paper. So because I cannot help you. Okay. So come back to the top first. Sorry. So format-wise, I would say first of all you should use larger font like this. You see you have tons of space here, so why not use larger font? And then you have to state or mention clearly what is your purpose. Is there a purpose slide? I don't think so. So introduction ends here, talking about the maze, and then suddenly you go to material and methods. So I don't know what does the study want to prove. I have no idea. Okay. So you have to state clearly. Okay. And then regarding the criticism, I think many of them are related to the fact that you have chosen a very difficult paper. I try to point some of them out, and I hope this can be improved next time. So first of all, you have to try to explain some of the terms. For example, at the beginning, you talk about asymmetries, but the symmetry can be easily explained with some images. Symmetry, asymmetry, then everybody knows what is asymmetry. You show the contrast. Okay, 对称与不对称, huh? Okay, and then next, you talk about pupil. You know pupil have many meanings. So you have to explain clearly with the image what is a pupil. Okay, because it has a lot of meaning. And not to mention you have a lot of anatomic terms, 解剖学上的名词 like iris, rostral, temporal, blah 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 blah, and so on and so on and so on. And this would really deserve a figure showing what is what. Anatomic figure. Like you can use a figure of the human eyeball to show what is rostral, temporal. At least that's what I did. I just Googled these terms and look for anatomic figures. Okay. Do not expect them to know this because I don't know either. So I don't think everybody knows. Okay. And so that's the main problem. So the terminology is not explained. Okay. So and then I think once you figure out, I don't think the explanation you provide is Stella regarding rostral and temporal is exactly correct based on my Googling last evening. So I really think you should do some study to know what this means anatomically. Okay. And then the second problem is, of course, related to the fact that you barely present any data. So, like this looks like come out of blue, 凭空冒出来的. I don't know what this really means. 30, 45, 60 degree of axis line. Yeah, I think you say that's the image I show in the paper, but in this case, you really need to show the figure, right? Otherwise, it's really like what? Yeah. And actually, I don't know what this is. So you really need to, it's your work to figure that out and then explain us in an easy way, alright? And then, so I would say, figure the terminology out, then present some of the data, and then, sorry, too wordy. And then you really need to digest the information and then return the words in an easier way. Because I think my understanding of your talks may be less than 30%. All right. Lastly, regarding the conclusion, because the understanding of the paper is not well, so you can see clearly where's the conclusion. Okay. All right, this is a bad example, having a black text above a dark background. Okay. Is that conclusion? Yes, that's conclusion. And you can see this has no information. This has nothing to do with the data in this paper. These are like, oh, we need to do more research. We understand them very little, so we need to do more. This, I don't even need to read a paper. I can tell you that. So this has no information. So you need to add more information, and to do that, you need to understand the paper. Okay? Okay. So thank you, Win.